Hey guys, today I'm going to talk about the slit experiment. So, this is one of the most interesting topics in physics because to do it requires very simple apparatus that you can actually perform it at home, but explaining it requires whole new fundamental physics. So, let's get started. Uh, the first thing we'll do is a very simple single slit experiment. But even in that single slit experiment, we'll choose the diameter of this hole to be very small so that light at least starts diffracting. And then we'll keep a light source here, which is a very weak light source. That is, it emits just one photon at a time. And then we keep a detector here at D. So, just with the basic knowledge of optics, you can uh, see maybe what's happening that as light travels, there are many paths it can go to, but there is certainly some directly available to it to go to D. So, some of the photons that gets emitted by this source ends up at D. Let's say that specific number is 2%. It may vary according to the different like apparatus here, but the exact value doesn't matter. Now with this we move to the double slit experiment. So let's say at some distance d1 I open up another hole, and what happens at this specific d1 is the detector almost stops making any clicks. So at this point, you might say that hey, maybe this the space right for light to spread out is now even more, and anyways, just 2% of it was ending up at D, and now that the space has increased to a lot more degree, almost none of it is ending up at D. But that of course doesn't work because let's say I give you another distance D2 and you open up a small hole there. What will happen at this D2 is in fact get 4% clicks, so that every 100 photon that you send from this source, 4% of it ended up will end up at D, which is even more than what you were seeing before. So it's what happened in this experiment was very difficult to explain in the classical sense because you can could not now anymore picture photon as like a simple classical body moving through space time and getting affected by some laws and moving through things, but it was somehow just affected by the paths it was traveling from and the distances of these slits and their sizes and where they were exactly, the number of them, all of that was affecting how what we were seeing as clicks on D. So this opened up a lot of controversies and a lot of gap in the current known physics and led to the invention of quantum mechanics. So what the scientists did is they made a lot of they guessed a lot of equations about what might accurately predict the observations that we are seeing. And they were just predictive models. That is, they didn't give a picture about what was actually happening here, and but just resorted to making predictions. So we'll try to understand that a little bit of what those equations try to do to get a flavor of quantum mechanics, and then I'll very shortly explain what are some of the problems in just viewing the world like that. So, but the equations that are involved will get very complicated in the slit experiment. So instead, we'll do those calculations or do that analysis for a simpler setup, which is called as the interferometer. So in this interferometer, there is like this semi-silvered mirror, which what it does is when you send light through it, 50% of it will go like this, 50% will go like this, and you can verify that by keeping detector in the same way we did in the case of single slit. And then there is a totally black mirror here, another partially reflecting mirror here, and a black mirror here. And this like whole apparatus is known as interferometer. So you shine light through it, and like the innocent guess would be that some of this would come out like this and like this, but thanks to quantum interference, all of the light ends up like this. So this is another example where the spooky nature of light shows up, and all of the light somehow, uh, due to what they call interference, constructive interference in this case, ends up in the rightward direction. And what the scientists will tell you about this is, we in physics now no more can describe things. What we can do is define, let's say, something called events. So what you want to know is probability that light comes out rightward. This is all that you can know using mathematics, that what is the probability that when you shine light like this, it will come out like this. And in making those calculating those probabilities, what you have to do is imagine that this photon which started here, it went through all these paths. It went like this, it went like this, and some of it also might have went like this, and all of the thing, and then finally it comes out like this. And all of the histories that you can imagine, right? Like h1, h2, let's say h1 was this path, h2 was this path, and lot and almost infinitude of all of them. We have rules to assign vectors to them, and these are called like probability amplitude. So for each history, you can imagine how the photon might have ended up from this point A to getting reflected rightward like this, which is the event we're interested in. uh, all of those histories, we have ways to give probability amplitudes to each of them. And then, because these are like probability amplitudes, you just add them up because there are different ways the event can happen, and the final amplitude which you get will denote the probability of E happening. And the rules are solid, they make the most accurate predictions ever. And for example, in this case, those rules will accurately predict that in fact this probability is 100, and this probability is 0. Yeah, and even in slit experiments, they will give you these exact numbers and all the variations, everything that can imagine in all those different experiments comes out very accurately using these way of calculating and this way of thinking. But there are many problems with this picture, because first of all, what we have now done by saying that you can only calculate probabilities is given the notion of indeterminism to the laws of physics. So for example, here, where the photon will end up, we can't predict. How it will end up, we can't predict. We just know that if you send 100% of it, in case of D1, 0% will end up at your detector, and in case of D2, of every 100 photons you send, 4 will reach. But you can't say which one of those 100 will actually reach D and which ones won't. So that was one major challenge. And if you have read that quote by Einstein, which was, God does not play dice with the universe, he was trying to oppose this very idea in quantum, which the quantum theory was trying to imply. The second thing is, when you are made to imagine these histories, right, and they showed up in any way in your calculations, they have to be real, right? I mean, for example, as we understand gravitation law, right? If you're studying planets and this is planet AB, you have some equation for what is the force of A on B and stuff like that. All of this is real entities, right? Like B is a real thing, A is a real thing. Force has to be a real thing. So that is why they show up in our equations. So in that very sense, when we say probability of every event is something summation of histories in some way, we have to actually give this histories the real sense, right? That they are something, some part of reality. And all of this was could not be put together, and these were very obvious criticisms that were given to this theory. And luckily today, both of them are solved by the theory of multiverse. The discussion of how exactly that is very nuanced, but I'll just try to give a picture. So one, how it solves indeterminism. So it what it says is that perhaps uh, the indeterminism exists in the sense that a history, in a particular history, the observers who watch this history can never be sure what will happen, but the summation of all of them, right, because they're all happening in the multiverse, in reality somewhere, is a very deterministic thing, that all of them happens. It's just that if you are in this history, you will see this thing. If you are in this history, you will see this thing happening. And the multiverses, they exist in like probabilities. So it's like in 50% of the universes this thing happened, in 50% of the universes that thing happened. But you could make that statement very deterministically that this will happen. So although the universe, each observer in a particular universe sees things randomly, the whole of the universe, which is the multiverse, has no indeterminism in it. And of course, by giving each history, it's being as a like considering each history as a separate entity, a universe in itself, we have uh, like given a real meaning to it, and there is no more non-realism that we have to accept about reality. However, as I said, the whole description of multiverse and all its different elements need a lot more discussion, but I think this gives a good enough picture of why that might be true, and hopefully explains why street experiment was so strange, and it's how it breaks down the classical picture and wants us to invent the non-classical or quantum model in explaining reality. And the third point is, if you could just, if it's just about seeing probabilities and the history and histories which are not real, that just gives a very weird picture of physics. However, if you follow the multiverse line of thread, multiverse thought of thread, you'll see these both pictures are have they somehow disappear, and we have very, although a very grand way to see the world, but it makes sense. Thank you.